This video will give you an overview of tidy data. By the end of this video, you should understand what features characterize tidy data, why tidy data is important in data science, and what features do R and the tidyverse have for storing and manipulating tidy data. So far with the material we've covered, R's data handling has been pretty limited. We've dealt with scalar or zero-dimensional data, such as the result of a mathematical expression, and we've dealt with vector or one-dimensional data. This is many values of the same data type that we were storing in vectors. So what are data like in the real world? The fact is we observe many things, like transactions on a website, shows that were watched on Netflix, or maybe fuel consumed by automobiles taking trips. While we observe a lot of different things, we also observe a lot of different attributes of those things. So when you're thinking about transactions on a website, you observe the items sold, the price they were sold at, the quantity, the order date. If you're thinking about shows on Netflix, you'd observe the series, the episode, and maybe the portion of it that was watched. For automobile fuel consumption, you might observe the number of miles that were driven, the vehicle make and model, and the fuel economy. The fact is, real-world data collects information of different types. And there are two ways to think about grouping information. First, by event. So with transactions, that would be each transaction, each sale on a website. With Netflix, that might be each show that was watched. And with fuel consumption, that might be each vehicle trip. The second way to group information might be by data type. So for transactions, you could think about the names of every product that were sold. That would be some text. You could think about the price at which each product was sold. That would be a double. Likewise for Netflix, you could think about the series name. That would be text. But you could think about the season number, which might be an integer. And with fuel consumption, you might think about the vehicle make or model, which is text, and the fuel economy, which would probably be stored as a double. Given these two different ways of thinking about real-world data, by observation or by data type, we generally think of real-world data as being two-dimensional. Observations group a single entity or event or measurement, and variables are a particular piece of information for each observation. We often arrange these data in a two-dimensional grid with observations on the rows and variables in columns. You might see data laid out like this in something like Microsoft Excel. And here's an example data set that I showed you earlier in the course. And you'll notice this is the exact form of two-dimensional data that we're thinking about. There's a number of columns. Each column has a name, and each column represents a specific type of information. The first important column is employee ID, which has an identification number for each employee. That's always numeric. Then you have the employee's first name. That's always some text. Their last name, likewise always some text. Their email address, which is a piece of text as well. Their phone number, which is a very specially formatted piece of text. And their hire date, which is a date. The information is also organized in rows, which are individual employees. And again, the employee ID 100 corresponds to Stephen King with that same email address, phone number, and hire date. So again, this format that's two-dimensional is called rectangular. Microsoft Excel stores rectangular data. Any table of data is rectangular. But it's important to focus on what's special about this particular two-dimensional format. The data I showed you in that image are tidy data. We'll deal exclusively with tidy data in a two-dimensional format in this course. This format's more restrictive than just a rectangle. Each value of a variable in tidy data has to be the exact same data type. So for every column, there's an associated data type, and every value in that column is of the same data type. So you can think of a column in a two-dimensional data set as being a vector. Likewise, there's a restriction on the rows. Each observation has to have an entry for each variable. So each vector of data needs to be the same length up and down. Sometimes an entry in a row might be missing, or NA. This is when we don't have information about a particular variable. We'll cover missing data in detail later. This two-dimensional data set in a consistent rectangular format, again, is called tidy. Why do we care about tidy data? It's important in data science for comparing observations. It's only possible to compare information if it's the same data type. Likewise, we'll compare about it for manipulating data. Anytime we'd like to create summaries or transform information, you need something to be a consistent data type if you're going to perform those types of operations on it. Lastly, the data need to be in a tidy format for modeling and visualization. If you're going to take data and convert it into a visual format, again, each piece of information that you're trying to present visually needs to be the exact same data type. So the tidyverse provides a special data type to hold tidy data, and it's called a tibble. We'll discuss this more in the next video, but tibbles hold rectangular data. There's one data type for each column, and every column is populated for every observation. This is going to make your life a lot easier as a data scientist because the tibble will enforce the tidy data format for you and provide a lot of features that will make your data analysis tasks easier. As a bit of background, Base R also has a tidy data format data type called the data.frame. Tibbles are an extension of data.frames. They do everything data frames do and more. Any R function that expects a data frame can generally be given a tibble. They're not even going to know the difference. But you'll usually only encounter these data frames in this class if you load data using one of the many non-tidyverse data loading functions. Again, another reason to stay away from those. And hopefully, you'll find tibbles as a useful tool in data science.